Yes. So the last topic discussion was gravitational force, and today we are going to discuss about gravitational field, right?
Yes, sir.
And gravitational field strength actually, and gravitational potential. So when we talk about gravitational field, gravitational field strength, and gravitational potential, so we have to consider some points जिसके ऊपर हम लोग बात करेंगे इंशाल्लाह, and by that topic we will move forward. Okay, so let's start with gravitational field. As I told you that when we will discuss this point, that gravitational field, so we have a perception in our mind that it was an area around the mass within which we can observe, or within which we can experience a force due to
Yeah.
that mass. But now in exam, actually this is your force per unit mass
Yeah.
at that point, right? So we
Yes,
will
sir.
define it right from here: force per unit mass
At a point.
was the gravitational field. But now I will talk about gravitational field strength in consideration. That के gravitational field strength आपके पास क्या है? So it is something same but a bit extended. Gravitational field strength at any point, because it is the above one is general description, but gravitational field strength is a specific discussion at a specific point. So when I say that gravitational field strength at any point, because it will depend upon the points, or it will depend upon the position. So at any point or any position is the force
Per unit mass.
per unit mass at that point, right? Is the force per unit mass at that point. So it is the same thing but bit extended at that point. So that is a simple concept what I have started with. And what you have to remember for this all, that is that gravitation field strength is represented by G, and let me write it here. It's this, its description. It is represented by G, and its unit is either meter per second square, or its unit is Newton per kg. Both are valid. I will explain both of them for you. So formula for G is, what is its equation? What equations you have to recall, or which are the which are, yes, what are the equations you have to recall and you have to derive? There are two main equations which are being used for this. One is that gravitational field strength is force per unit mass. So that is the defining equation, right? What do we call it?
Defining equation.
That is our defining. Define कर रही है ये उसको. But when we will talk about the extended equation due to that force by which it is being obtained, then I will talk about something else. But right here, I will make a unit from this one. So due to that, it is its unit as Newton per kg. So you know the gravitational field strength at the surface of Earth is actually equals to 9.81. We were talking it that it was meter per second square, but we can say it is Newton per kg, right? It can be written in the same way that G on the surface of the Earth is equals to 9.81 meter per second square. So both gives the same meaning, but that means that if I have if I have an object of 1 kg on the surface of the earth, then this object will be pulled by the earth by a force of 9.81 Newton. So it is 1 kg mass, and it is attracted by the earth by a force of 9.81 Newton. So that is why its field strength is called 1 Newton, I mean 9.81 Newton per kg. This was the defining formula and defining equation. Now I will move forward, and the second equation which you have to recall, that is recall and derive. That was included in the syllabus. If you remember, I have shown you all the specs of the syllabus, that what you have to recall and what you have to derive. So this is the equation you have to recall and you have to derive. Its derivation is just mm, nothing. It is quite easy. I mean, I will consider that they are the free marks. So recall के लिए आपने जो equation याद रखनी है, that is minus g m divided by r square. This is the equation you have to recall. Okay, what is that equation? This is equation you have to use, as well as you have to recall this equation for your convenience. मैं इसको explain कर देता हूँ कि what is m, what is g, and what are r. Where m is mass of planet, big planet, mass of planet, not the object. Remember one thing, this is the important thing what I wanted to tell you. And g is gravitational fields, universal gravitation constant, so its value is 6.63 into 10 raised power minus 11 Newton, kg minus 2, meter minus 2. And then r is this distance
It's a
between,
bit.
or separation between the centers, right?
Yes, yes, sir.
So separation between two bodies, two centers rather. Okay, so let's talk about its derivation. Its derivation is very simple, and it is coming from the defining equation. That is, if we write g is equals to f by m, and that gf is minus g mass of the planet, mass of the point mass or object, divided by r square into this m, what is here. So I will just use the same color for these two m's, just to make sure that F is extended with blue and M is with black. So M and M will be gone. So your equation is now derived at very simple way. Check this one out. You got this result. Is it? So it's quite easy. It's not a big deal.
Okay.
Okay. So there are some specifications of that, and one of that is when I say that variation in G. तो वेरिएशन इन जी थोड़ा मैटर करता है, जिसमें मुझे थोड़ा आपको एक कॉन्सेप्ट देना है. वेरिएशन इन वैल्यू ऑफ G. So variation in the value of G has two aspects. Okay, that those two aspects are, one, I will consider it above the earth surface or above the surface of the planet, and the second one is below the surface, right? So as I told you, that above the surface of the planet, above the surface, it varies according to inverse square law, by inverse square law. Okay, so according to that concept, inverse square law, as I told you, that G is inversely proportional to R square.
Also,
So if I draw the graph of this, it would give you very easy description, that if you are having a graph of G with R, right? R is not a fixed value. That is basically the value of any distance. Okay, so this is the surface of the planet. So I mean, this is the planet actually. So if I say that this is the radius of that planet, ये center है ना basically. So it would be maximum at this position, which is your R. Let's say it is your 2R. Let's say it is your 3R. Let's say it is your 4R. So G is highest or maximum at the surface of the planet. So let's say for this planet, G is this much. Let's say it
Yes, sir.
is G. For example, if we talk about Earth, suppose it is 9.81 here, or let's say it is 10 here. Now, as I move to double the distance, that R would be reduced to 1/4. 1/4 is coming here at this point, is it?
So double the
Then
distance
1 by
R
16.
increased to 4.
Yeah,
But
R is increased by 2.
yeah,
R
but 2 R
is
2 R
actually,
square. So 4 R square. So 4, you know?
no. 4 G will be decreased by 4,
Yeah, that's what I'm
right?
saying. So G decreases by 4, but R square value increases by 4.
Yeah, R is multiplied by 4 and
Yeah,
G is
decreased
decreased
by 4.
by
Yeah,
4.
yeah.
This is
Oh,
what I want.
I
So
understand.
actually, it means that this graph would be something like this. Okay,
Yes.
but this
Yeah.
all is above the surface of the planet. So here it is the highest value of G. G is 9.81. So it follows inverse square law. So this is what you have to remember, or this is what you have to consider for above the above the surface. So I will make it clear from an equation. For example, if this is the body and this is there is an object which is basically uh, which is away from that body at at a specific distance. Let's say, let's make it as a distance. So what do you think, if that point is that mass is here at distance r, then this mass is at this point at 2r, then this
Yeah.
mass is at 3R. Now, let's say this is the significant distance. Sorry, when I say that this is the distance, this distance is not significant. This separation is not significant as compared to that of the radius of the Earth. Rather, I will say that this is actually equal to, this separation is equal to the radius of the Earth, isn't it? Do you
Yeah.
believe this thing? Right? But when this object is over here, let's say an object is something like a person who is moving upward away from the surface of the earth, moon की तरफ जा रहे हैं हम लोग. So will you think that this now uh, at a certain position the distance will become significant from the center of the earth? Let's say मैं इस point पे consider कर लेता हूँ. This
Hmm.
is the point where this is the total r, but this r consists of two separate positions. Check this one out. This is your capital, sorry, this is your height h,
Yeah.
or this is your, you can consider it height h. Height का मतलब हमारे यहाँ हम लोग इसको थोड़ा सा मिस इंटरप्रेट करते हैं. That is, height does not mean that you are going up from the surface. You can go away from the surface. It is considered as height.
Okay, sir. Yeah.
बात समझ रही है? So if I consider G at this point, the surface of, I mean the body value of G at certain height h, then I will get that this is capital G m divided by r plus h whole square, isn't it?
Yes, sir. Yes.
Is it na? Because ये
Yes.
so small r है. Because when I put this all in my calculations, as I told you that G is equals to G m divided by small r square, and then this G is equals to minus G. Mass of the planet is not changed, and this is your capital R plus h whole square. So as height, I mean as h increases, as h increases, G will decrease. It is obvious from this equation also by inverse square law, or you can further expand it by using some sort of your binomial expression, or you can use this by your square formula, a plus b whole square, right? But no need at all. But you have to consider one thing, that value of g at any position above the
So the
surface
surface
is
of the Earth is less
sorry,
than. Yes, sir.
yes, that
Yeah.
is equals to g m divided by r plus h whole square whole divided by g m divided by r square. So when I will
Yeah.
make this as a when I will put it in the rule of fractions, I will say that this will become r squared divided by r plus h
The whole square.
whole square. This is actually the formula because GM cancel हो जाएगा ना. So gravitational field strength at any altitude or at any height as compared to that of the at the surface of the earth at any distance. Actually ये formula मैंने किस वजह से दिया हुआ है? At any distance, that was actually r divided by r plus h whole square.
Yeah.
Is this clear to you?
Yes, sir.
So आपका h बढ़ेगा तो योर gh की वैल्यू क्या होती जाएगी? It would be decreased by a factor of inverse square. So any confusion in this one?
No, sir, not this.
Okay. Now let's discuss that the value of g below the surface of earth.
Okay.
Below the surface of earth. Now this is very interesting fact that if I consider that the value of g is what will be the value of g below the surface of the earth, I would like to have a diagram shared with you. I believe that it will help me out. That when I want to make a hole in the or when I want to dig the earth down, तो उसके उसके diameter को अगर मैं क्रॉस करूं and I want कि यार I would move across it. So will it be just like a tunnel?
To reach center of the Earth.
Yeah, to reach the center of the earth.
Yes, sir.
I'm gonna share one diagram with you. Check
There's
this one out,
vent
and
and
then
then you have to go through the center, like the different layers.
yes.
Ah.
So yeah, isn't it something like this?
Yes, sir.
ऐसा ही करना पड़ेगा ना. So actually, what is happening to me that is that if I am here, this is the shuttle or just a tube which is being used to transfer or to travel through or an object. Then when I will drop this object, right, what will happen when it will reach to this center? It will not come to rest here, right? It will move this or it will cross this direction, cross this position, and then it would move to the other. Then it would be attracted back and forth. So in this way, the object oscillates in between. So just consider one thing. If you are going to dig the earth down, you are making hole in that. So this outer earth is now of no use for you, है ना?
Uh-huh. Okay. Yeah.
Because now the force will be provided or force will be acting on you that will be due to point mass. तो ये जो hollow होती जा रही है इसका तो कोई point mass का concept नहीं है because it will not be acting just like a single particle or it will not behave just like a single particle. तो ये तो सारी की सारी गई. This all earth I just consider it that I have eliminated it. I have cut it out. So when I will cut it out, now my internal or entire earth will be this one.
Uh-huh.
Or do you believe this thing?
Yes, yes.
Okay. So अगर आपकी अर्थ ये है and you are digging it more into detail, more आप नीचे जा रहे हो. जब आप नीचे जा रहे हो तो बेसिकली आप क्या कर रहे हो? आप और इसका रेडियस कम कर जा रहे हो, करते जा रहे हो. So the remaining radius will be small enough. Is it? Small होता जाएगा ना?
Yes, sir.
So when I will reach to this point, let's say closer to the closer to the surface, so मुझे ये लगेगा कि यार द रिमेनिंग अर्थ इज नाउ दिस मच ओनली, सो व्हेन दिस रिमेनिंग अर्थ इज ओनली दिस मच, तो आपको ये देखना है कि द mass of the earth is decreasing, density of the earth remains unchanged, is it? Density is only general of the earth की, volume decreases. So this is what I've considered. Okay, initially, what was the distance or what was the radius of the earth? This was the complete radius of the earth. Now what is the radius for this one? If you have gone d into, this is d you have traveled, so remaining radius is how much? This is the remaining radius. So what is that? It is r minus d. Ab aur niche chale jao, and so on. So I can just make a single diagram for you, just to consider that you are here inside the earth, and when you are here inside the earth, you have gone through d distance below that, and this is total. तो अब आपके पास यहाँ पे आप बैठे हुए हो, सो यू आर एट व्हाट डिस्टेंस? एक्चुअली यू आर एट अ डिस्टेंस ऑफ r minus d, is it? Am I right?
Yes, sir. R1 is the
So
inside
this
the
is your earth now, है ना? ये बच गई ना सारी अर्थ मेरे लिए.
G.
Now I will use that formula that G, oh, sorry, the force which is acting on my body right now, that force is, sorry, the gravitational field strength I was going to find. The gravitational field strength over there is force per unit mass, as my mass is not changed. But when I will talk about the force is minus G
The
mass of the earth or mass of the object divided by r
R square.
minus
R minus
d
D the whole
whole
square.
into m.
Yeah.
Okay, so from here you can cut these m's, and now you can find that what will be the value of g for you. That is g m. Actually this is new mass, so I'm just going to give a prime or just a symbol to show that r minus d whole square. अब प्रॉब्लम पता है क्या होगा? As you have reduced the mass, so your volume is also reduced, so you will use the formula of the density. The density of the earth is uniform or a constant, and that is mass divided by volume, isn't it?
Yes, sir.
So mass is density into volume. Let me write density in this way because it will make you confused in के diameter है या density है. So check करिए जरा. So the mass is now equals to density of the earth into volume of the earth is 4 by 3 pi r minus d whole cube.
Yes.
Are you agreed with me?
Yes, sir.
Okay.
Agreed.
Now I will replace this entire value
For mass. Okay.
for mass, right?
For mass.
So
Yes.
when I will replace this entire value for mass, actually my new setup will be value of g is equals to minus g rho 4 pi divided by 3 into there. I have just put all the constants outside, ठीक है ना? So r minus d whole cube divided by r minus d whole squared, and so on. So
So R
just
minus D whole cube divided by R minus C whole square gives you R minus D.
yes, it would be cut now. So
Yeah.
your new equation will be g rho, I mean 4 by 3 g, yeah, 4 by 3 pi g rho into r minus d. So if I say that as you are getting deep into your value of g, I mean factor of g is reducing, इसको थोड़ा सा और simplify कर देता हूँ मैं कि g is equals to k times r minus d. Am I right?
Yes, sir, because it's constant. Yeah.
Yes, so because everything is constant, na? 4 by 3 pi g rho आप इन सारों की वैल्यूज प्लेस कर सकते हैं एंड यू कैन गेट अ प्रॉपर आंसर. सो एज आई से that value of g is equals to k into r minus d. So as you go deep into, as d increases, what about g?
So as D increases, minus so positive minus positive is lower. Decrease, decrease.
Yes,
Yeah,
that is the point. ये
yeah.
सारा कुछ कांस्टेंट है. यहाँ पे आपने ये जो माइनस वाला साइन था ना साथ, इसको भी साथ ऐड कर लो. So for this I mean for this all, if I say that inside the surface, inside the surface, I can say that if I have this much radius of any sphere, any planet, then at this point value of g was this much. This was the value of g. कोई भी वैल्यू ले सकते हो. लेट्स से ये g की वैल्यू है, राइट. इट वाज 9.81 surface of that layer. So when you will go deep into, I mean यहाँ से आप deep जा रहे हो, यहाँ से आप जा रहे हो, यहाँ से आप जा रहे हो, यहाँ से आप जा रहे हो, you reach to this point, your value of g will decrease, 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 and decrease to zero. Now is it clear?
Yeah.
Is this fine? So अब मैं थोड़ा सा इसके साथ extension कर रहा हूँ, extension कर रहा हूँ this way. This is the extension, and I will draw a line of this much. Okay, basically, if you have this graph, so isn't it a perfect description that this is the extension above the surface and that red one is below the surface? This is for inside and this is for
Out.
outside. इसमें कोई
Sir,
confusion तो नहीं?
sir, can I use the washroom? I need to print them out as well.
Sorry, can you repeat?
Sir, can I use the washroom? I need to use. I need to print them as.
हाँ, नमाज पढ़नी है.
Yeah.
सिर्फ 5 मिनट दे सकते हो.
Okay.
ठीक है, जस्ट 5 मिनट के बाद मैं बेसिकली टॉपिक स्विच करूंगा, तो उस टाइम आप नमाज पढ़ लें, मैं फिर पोटेंशियल के लिए दोबारा से स्टार्ट कर लूंगा. अब आप देखो, दिस वाज ऑल अबाउट ग्रेविटेशनल वैल्यू ऑफ जी, बट दिस टॉपिक गिव्स अ ह्यूज स्टफ फॉर आवर क्वेश्चंस, कैलकुलेशंस, एंड स्पेशली जो आपके एग्जाम में इसमें से एरिया आता है, दैट इज कैलकुलेशंस ऑफ what type of calculations are being asked from here: density,
Okay.
mass,
Yeah.
radius, everything. ठीक है, और आपने फॉर्मूला याद रखना है, राइट.
That's the mass by
दैट,
volume.
यस,
Hmm.
दैट इज, फॉर एग्जांपल दिस इज द रेडियस ऑफ दैट अर्थ. तो मैं सिर्फ पूरी अर्थ का अगर मैं रेडियस कंसीडर करूं, तो आई कैन से दैट value of g in the form of entire earth is equals to 4 by 3 pi r divided, sorry, pi r g into density. Yes, this is the formula. ठीक है, इसकी डेरिवेशन भी आएगी. ठीक है, entire stuff, if I'm not wrong, everything is, everything I have put inside. तो आपकी डेरिवेशन किसी भी फॉर्मेट में आ सकती है, बट you have to start from what? F divided by m, then after that you have to switch to g m m divided by r square
Where
into, yes, into छोटे वाला m, it would be gone. And then from this one, actually ये फॉर्मूला सारे का सारा आपको अगर मैं ये बताऊं, it will be g m divided by r square. You can make this as a reference for you.
yeah.
If you will use this one, अगर आपको mass की calculations वो करवाता है, तो you can just substitute mass as density divided by volume. And then if mass is not available in this one, check करना जरा. अगर mass नहीं है, तो आपने क्या करना है, यहाँ से mass को उठाना है. So mass is equals to density is density divided by 4 by 3 pi r cube. So this would be transformed back and it would become 3 रो डिवाइडेड बाय 4 पाई आर क्यूब। इसको आप
Yeah.
यहाँ पे रिप्लेस कर दो, तो यू विल गेट वैल्यू ऑफ जी एज जी इंटू 3 रो डिवाइडेड बाय, सॉरी 3 बाय लिख देते हैं जस्ट फॉर कन्वीनियंस, नथिंग एल्स, सीक्वेंस वही रहेगा, एंड इट विल बी योर 3 रो जी divided by 4 pi r cube.
Okay.
And yes, did I make a mistake in this 4 by 3 pi r cube? Mass density over volume. Oh, sorry. Oh my god. Just in hurry, we made a mistake. Density is mass by volume. So mass is density into volume. Oh my
Yeah.
god. तुमने भी नहीं मुझे बताया ना लड़के, 5 मिनट को तुमने एक्सटेंड करवा लिया। सही है। सो फ्रॉम हेयर यू कैन जस्ट सिंपली पुट द वैल्यूज हेयर एंड यू कैन गेट द वैल्यू ऑफ जी के। आपके पास क्या हो जाएगा, 4/3 रो जी इंटू आर। ठीक है ना, ये वैल्यू हमारे पास आ जाएगी। 4/3 पाई भी है, यस पाई भी है, एंड इट वुड बी आर। आफ्टर सम कैलकुलेशंस वैल्यूज प्लेस करनी है आपने, डेंसिटी की जगह डेंसिटी ही रखना है, वॉल्यूम की जगह आपने क्या कर लेना है, 4/3 पाई आर क्यूब लगा देना है, एंड देन यू विल सब्स्टिट्यूट इट। एंड इफ यू वांट टू फाइंड आउट रेडियस फ्रॉम हेयर, आपसे रेडियस की कैलकुलेशंस भी वो करवाता है। दैट इज 3 स्मॉल जी डिवाइडेड बाय 4 rho g pi. So anything can be asked to you, but
Yes.
main theme is never changed. ठीक है? Is this
Yes.
clear? So आप
Yes.
नमाज पढ़ के आ जाओ, and after that I will switch it to the potential and we will continue back.
Okay.